As Stefan said, I lead marketing for Cisco Systems service provider business. And as part of that responsibility, I oversee a thought leadership team we have. This is a small group of brilliant quantitative minds and subject matter experts that we kind of push off to the side, keep them away from everything else, and we lean on them to advise us on the actual trends that they see coming out in the future to help guide our overall engineering roadmaps. And that was very much the genesis of the Cisco Visual and Networking Index. It is, we started to advise our engineers, and in the process of socializing it with others, they asked to use it, and now it's been nearly a decade and is keeping that team quite busy, making sure it's reflecting the latest and greatest in the industry. Now, part of the reason I think there's so much attraction to it is because it's a very rich and complex methodology. We take third-party inputs from various analyst firms, including Telegeography and many others. We have more than 24 broadband feeds from service providers around the globe that allows us to analyze this anonymous data. And we also have more than 1.5 million people using our applications on their various devices. And every time they use it, it feeds additional information back into this study that we're able to go and publish them once a year. Now, because of that type of methodology, we find that overall it tends to be quite fairly accurate. Usually we're within about 10% of the actual projected growth. In this particular case, you'll see that we estimated in 2010 IP traffic in 2013 was going to be just under 50 exabytes a month. The actuals were around 51.5 or so, and so those were around 3% accuracy. More often than not, we are on the conservative side. In fact, that's part of our methodology. When we need to look at various assumptions, we'll go for a more conservative approach. There can be some situations, like a few years ago, with the macroeconomic conditions in Europe slowed their overall mobile broadband build-out, and as a result, we were a bit aggressive. But then that's why we do this every year, is to continue to refine the methodology and reflect the latest changes. So let's get on with the findings of the study. This is for the years 2013 to 2018, and we anticipate overall traffic is going to increase threefold. Rising from 51 exabytes a month up to 132 exabytes a month, which reflects about a 21% compound annual growth rate. Now, if we start to extrapolate this on an annual basis, that means that by 2018, we will actually be having an annual run rate of 1.6 zettabytes a year. Now, when we started this study years ago, we measured everything in petabytes. Then we moved to exabytes, and now we're into zettabytes. So we've had to change the unit of measurement multiple times then in less than a decade. Now, a zettabyte, in addition to being a really fun word to say, is about 1 trillion gigabytes, or 10 to the 21st power. And 1.6 zettabytes is the equivalent of about 13 times all of the internet traffic that existed in 2008. Now, the reasons for this growth are many. But they include the fact that there are more users that are coming onto the network, and we'll talk a little more about that. There are more devices, of course, from those users, as well as an increasing number of machine-to-machine connections. The faster broadband speeds, in this 5-year time horizon, we're anticipating overall broadband speeds, both fixed and mobile, will increase an average of 2.6-fold. And more, the usage that we're seeing on the network is video. In fact, video is going to comprise about 79% of all the IP traffic in by 2018. So the network is inherently becoming a visual medium. Now, diving a little more onto users, we estimate there are going to be nearly 4 billion users by 2018, which, if you look at the UN modeling in terms of anticipated population of about 7.6 billion, will mean that more than half of the world will actually be connected onto the internet. You'll see the overall growth rates vary by region. North America and Western Europe, you'll see, have a very low compound annual growth rate, in large part because the overall internet penetration levels are so high. Asia, and not only has the most amount of internet users, which makes sense based on its overall population size, but also has a very strong compound annual growth rate as well. So we're seeing some incredible growth there. One thing to note about Asia, it's always difficult to put this into any one category because there's such such developed markets there, some of the, really the most advanced in the world, as well as some more developing markets. So if you go online, you can actually get details at a per country level as well. Now this is an interesting situation because it tends to be flipped then when we start looking at overall device growth. We're anticipating about 21 billion network device and connections. And you'll see the very strong growth rate in North America and Western Europe that already had high internet penetration. And that's in large part because in these developed markets, people are looking to connect more and more things. They get a lot of value out of that and as are investing. In fact, if we go through a count of the number of internet-connected devices that the people in this room has, I'm sure it'd be well above average. Asia Pacific, though, is interesting because not only do they have the most internet users and a very strong growth in terms of internet penetration, also has a very strong growth in terms of the overall number of devices as well. So really, Asia Pacific is getting both on the users and the devices some really dramatic growth. All in all, there'll be about 2.7 devices or connections per capita, and it was very much in line with a comment made in a session yesterday about the need for mobility. More than half of all those connections are going to be touching the mobile network. So as network architects, we need to look not just on one means of access, but really this type of growth is going to be affecting it in every single way across the entirety of the architecture. Now, there are a lot of different trends that we have within this study, and you can slice a pie a lot of different ways. We actually go through and look at 10 different trends, spanning everything from the effect on tiered pricing to broadband growth, content delivery networks and their important role in delivering video. Wi-Fi technology is very interesting as well. And we also have a whole study on the different services that are driving that growth and the variances that you can have per region. But given the time limitations today, I'll go and just highlight just a few of those, in particular around one of the major device transitions that we're analyzing right now. And that's going into the rise of 4K or Ultra HD television. You can see from the left side, the standard definition requires about a 2 megabit stream. HD goes up to 7.2, and Ultra HD hits to 18 megabits per second. And it's going to go even farther if you looked at the demonstration of 8K from NHK that was yesterday and the day before. Stunning picture. That's going to go up to 85 megabits per second once compressed. So as you look at this particular one, though, just as the growth of ultra-high definition televisions starts to go on the right-hand side from only 1 million in 2013 up to 202 million, then the impact of those devices can yield significant changes in the overall broadband landscape. I received a Ultra HD television over the holidays, and it is absolutely awesome. I mean, it really kind of pulls you in. You want to watch more and more television as a result of that. But then my personal footprint on the internet landscape then becomes significantly higher, because even though Ultra HD televisions are only going to represent about 20% or a fifth of all the televisions out there, it's actually going to it's going to account for 8% of the total traffic across all devices and across all mediums. So just that one device now can make really a sizable dent on the overall landscape. Now, another big growth trend that we have seen and that we spoke about during this session has been machine to machine. And on this particular one, we start looking at the overall number of connections. We're looking at machine to machine being about one device per capita on the globe, reaching about 7.25 billion different connections by 2018. Now, most of these connections usually don't have a great deal of bandwidth. With the exception of something like a video surveillance, most of them are going just to be, they're going to be optimized to have very low amounts of bandwidth. But the important part is to look at it, even though it may just be a heartbeat or a query ping that goes out from these various sensors, because so many of them are going to be connecting to the mobile network, it puts incredible strain on the signaling plane of the mobile network as well. So we always encourage our customers when we're reviewing this data with them, don't look at this as just a bandwidth situation, but more reflective of other aspects of the architecture as well. And you can see that the overall amount of growth, I mean, this particular machine in particular is going to be growing the fastest of all the different types of devices that are coming onto the network. It will be increasing from about 18.5% in 2013 of all the devices to over 35% of all the devices. So this is the one area to really keep an eye out and see how it continues to evolve. Now, another interesting aspect is that you start looking at peak versus average IP traffic growth. If you just take the overall average findings and apply them out to the network, we're going to miss it by a mile. And that's because just as in back on the voice network days when architectures had to be optimized for the Mother's Day phenomenon, when everyone's picking up the phone and calling their mom and need to make sure it was going to work, now we need to actually make sure that the networks are working during these peak periods by day. And we refer to that as the internet prime time, which goes between 9 p.m. and 1 a.m. when we see the largest peaks on most of the service provider networks. So you see the average hour is going to be increasing at that 21% compound annual growth rate, but the peak hour actually is going to increase faster, which means that the wider this divide, the more capacity and issues that are going to be coming into the network need to be factored into account. And because this is usually when people are starting to stream video, then it brings into account all sorts of latency issues as well that need to be factored into play. In fact, if you look at the variance between the busy hour today, which globally is about 2.7 times higher than the average hour, we anticipate it's going to be 3.3 times higher than the average hour in 2018 because of this preponderance to watch more and more video. The gap is even larger in Asia Pacific, where it's going to be going to 2.5 times fold increase in 2013 to reach a 3.2-fold increase in 2018. So lots of different aspects to take into account there. The last one I'll highlight was mentioned yesterday as well is all going to be around IPv6. And one of the panelists says, as an industry, we need to do better on IPv6, especially with all these different connections coming on. It's just going to be necessary to really keep the ecosystem thriving. We'll see that from 2013, we had about 16% of all the connections, around 2 billion were IPv6 capable, and and by 2018, we anticipate that to be nearly 50%. So in this next half decade, there's going to be some very strong growth, in essence, effectively tripling the number of IPv6 devices, but it's still going to be a long ways to go before we fully made that transition. And as a result, we should expect technologies such as network address translation to be in the networks for well past the forecast period of this particular study. So I'll leave you with some closing thoughts on this session, that as much as we can in a forecast look to estimate all the activities that are going to be taking place and then what is the resulting effect, there always can be some things that get in the way and that can yield different outcomes. There can be the macroeconomic situation that I spoke of. There can be some geopolitical situations which can actually remove certain countries off the internet itself. But there also can be a number of surge events that can take place, whether it's a national incident that requires lots of people to get news, whether it's something that a national passion that everyone wants to be engaged in. And we saw that in the Sochi Olympics, where several of our operators had peak demands more than double their all-time record, all because it was a hockey game, and it was during the work hours, and people were watching the hockey game on their mobile phone, or a cross-country ski race that we're seeing just for these big surges that can take place. One of the most recent ones that is of note was what we refer to as the network effect of the beautiful game. If we look at the World Cup last summer, there was 4.3 exabytes were streamed, which is the equivalent of 3 times the monthly internet traffic of Brazil alone. So even these different elements can come into line and really can have a market effect on the landscape. So I encourage you to learn more. I'm sorry we were a short time. We can't necessarily go in. I could speak on this all day, but we do encourage you to please look at the various research we have. Use it liberally. All we ask is that you please source it to Cisco VNI. Thank you very much for your time. I'd like to thank the host for being outstanding to myself and all of my Cisco colleagues. And thank you all for being there and for the ongoing discussion about how we can make this industry thrive. We're very much thankful for it. And we look forward to seeing you again and continuing the discussion in the months to come. Mahalo.